All right. So Jamie had a really good question. I put it into the chat. If I think everyone was on here when I did that. And it was a question about baseline insulin and then also utilizing a sliding scale. And then I'm going to get some clarification on that from Professor Geyer and find out just exactly what type of question that is, so I know how better to answer that question. So if I get some feedback on that between now and this afternoon, I will let you all, or I'll at least put it on the afternoon recording. That way you have some understanding what that is. So I in the OneDrive folder, the shared folder, I updated this for the summer 23 summer, the study guide that Madeline put together, or Maddie put together a couple semesters ago. I'm assuming she's graduated and practicing nursing now. The questions are all the same. I just cleared it out that way when I mark on it, it's fresh. And then you'll be able to pull that up and see the marks that I make on it after, but you'll also follow along on the YouTube recording. So you've already gone through and you've already taken a couple of these dosage calc tests, and it's just another one to take. As a reminder, these are some of the the conversion factors you need to know off the top of your head. Like you can't, they won't be given to you, so you do need to know. I will say that I've never seen any of the nursing classes do any of the centimeters, millimeters, and things like that, but they're there. If just as a review, I've not seen going from inches to centimeters. I think you see that a lot in your ATI, but not on your dosage calc test. So what one of the things that I think is good that Maddie did when she created this is she went through your 230 blueprint and basically highlighted some of the things. So like it tells you, you're going to have questions. You're going to have 2 questions on household measurements and converting between systems. And so she wrote out the household conversions and the metric conversions. So if you do get like, convert, 15 inches to 2.54, to centimeters, then you have those conversion factors there. So it'd be good practice. You're going to have some metric unit conversions. She said kilograms to grams, but I would expect that you're going to see more like milligrams to micrograms, micrograms to milligrams, and milligrams to grams, grams to milligrams, as well as going from pounds to kilograms. We usually don't talk, at least from what I've seen, talking about kilograms other than talking about a patient's weight, because medications typically aren't going to be dispensed in kilograms, right? They're not that much that they would be receiving that much. You might get 2,000 milligrams, which is 2 grams, but I'm doubtful that someone's going to get 2,000 grams of something. That's usually, like, I always joke, like when they, bust somebody that they think is trying to sell drugs, like, marijuana and cocaine and things like that, they are measured in kilos. Like he had, 2 kilos or a kilo of some illicit substance. And so just to kind of keep that in mind. I think hopefully at this point you've seen enough of these intake questions with the, the juice, water, milk. There are a few nuanced things that I'm not 100% on, and maybe and hopefully you are, like the whole, like, if there's ice chips, like, how you handle that, but it looks like it would be half the volume. So if it's 8 ounces of ice, it's 4 ounces of liquid. Drinks, you would calculate Jello, which is predominantly liquid. You would calculate broths. I don't know about ice cream, because ice cream doesn't seem like a liquid to me, but maybe it's because it's like milk, and I guess that's why it would be there. So they tell you 4 ounces of ice cream, you would treat it as 4 ounces of milk. You would ignore a fruit cocktail, because even though there's liquid in the fruit cocktail, it's minimal. Most of it is the fruit. And then popsicle, like, if you've ever seen a popsicle melt, right, or sorbet melt, then you know it becomes liquid. So I think you guys know that. The oral medications, 1-step and 2-step, you should be fine. When they talk about 1-step, it's what you've done over and over and over again. That could either be doing a solution, like in this example, you have an order of Tylenol, 160 milligrams to be dispensed every 6 hours. The pharmacy dispenses 80 milligrams per milliliter. And then sometimes, and I would say probably on your test, it's not going to tell you how many milliliters we administer per dose. It would just say, how much would you administer? And you would just, if you're doing this, and I think you've seen this enough times, if you're doing dimensional analysis, you can take your order, the 160 milligrams, and then convert it from milligrams to milliliters. And so you'd give this patient 2 milliliters. Okay. And that's over 1 if you needed to see that. If you're doing ordered over half, 160 over 80 times 1 gives you the same answer. Okay. So what you're looking, make sure that you know your units. And the way you know your units is it will typically tell you in the order. So it's either 80 milligrams per milliliters, 80 milligrams per tablet, 80 milligrams per capsule, 80 milligrams per teaspoon or tablespoon. Those are the things you want to make sure you're paying attention to and on your labels. But you've seen those now for a couple semesters. So my hope is that you have a good idea of what those look like. So that would be an example of a 1-step problem. Here, the second one, a 2-step problem, usually incorporates the patient's weight. So you have to do an extra step. So it tells you child weighs 73 pounds. The order is 3 milligrams per kilogram every 6 hours. And then you have available 50 milligrams per 2 ml. Okay. So if you're doing this, you can do this any number of ways. There's no one right way to do this. I know some of the other campuses, and I can't remember if it's Boyce or not, you have to kind of do all your steps in one kind of arrangement, which you can do. I usually like to chunk it, meaning I like to start off with the patient's weight, 73 pounds, and then convert that right away. Oops, that's not what I meant to do. Convert that right away to kilograms. So you should remember that for every kilogram, it's 2.2 pounds. And so what you're going to do is with your calculator, 73 divided by 2.2. And you're going to get 33.18181818. And I typically advise you to just go ahead and round to the 10th. I will show you an alternative way if that's what you've not been told to do. So 33.2 kilograms. And then I would just multiply by the 3 milligrams per kilogram. And then I would multiply by the 2 milliliters per 50 milligrams. And I'm going to show you an alternative way to kind of set this all up. But the reason this is 2 steps is because step 1 technically is just converting kilograms to milligrams. And then step 2 is converting milligrams to milliliters. Now, the alternative way, if you needed to show like all your work all as one step, which some of you may prefer that, some of you may not, is you can still start off with the patient's weight. Still convert it to kilograms. Now, instead of setting that equal, just keep going on with your conversion factors. Okay. So we know we're trying, at this point, we're trying to get rid of kilograms. And what it tells us to do in the problem is that there's 3 milligrams per kilogram. So we can still make that as 1. And then ultimately, if we're trying to administer a dose and the dose is available in 50 milligrams per 2 ml, the 2 ml tells us, the ml tells us that that's what we're looking for. So 2 ml here, 50 milligrams here. And then I can just work it all out. I've noticed that over the years, nursing students don't really like to look at this because there's a lot of numbers here, but all you need to do is multiply across the top. So 73 times 3 times 2, and then divide by the bottom, divide by 2.2, then divide by 50. I'm basically going to get to approximately the same answer here. So let me just show you what that would be. So the top one there, the 30, where I had done 33.2 times 3 equals 99.6 times 2 equals 199.2 divided by 50. And I'm going to get 3.984 milliliters. So if they're asking you to mark on a syringe, we're probably just going to go ahead and round that to 4 milliliters. So let me see what it does down here without doing the accounting for the rounding initially. So 73 times 3 times 2 gives me 438. Then I'm going to divide by 2.2, and I'm going to divide by 50. And I'm basically going to get the same answer I got before. I'm going to get 3.981 repeating. So it goes 981, 81, 81, 81. You would just round that again. Technically, you should round it to 3.9 but you're looking at this, you're looking at the hundredths place to see what to do with this. That should be rounding up. So 3.98. I think the right answer, the best answer would be the 4 ml. You're not gaining any additional medication by giving them that extra 0.02 milliliters. So if that helps to kind of give you a little bit of peace of mind with that. I always find that if you're doing a paper test, you can show your work. But obviously, I know that a lot of you end up doing the Blackboard test version, and you have less opportunity to show your work other than what's on your scratch paper. But usually the questions aren't as like really close here, like the 3.981. But if it is that close, I think you are safe to go ahead and round to the whole number in that instance. If you have something like 3.35, then you would round that to 3.4. And I'm hoping that you have a good handle on your rounding rules. For IV.
Dr. Red, I'm sorry,
Yeah.
I have a question.
Yes, go ahead.
Way to do those type of two-step problems desired over had?
As long as you get to before, remember, desired over have or ordered over have, you have to get to this, you have to account for this step first. So step 1 has to be taken care of first, then you can do ordered over have.
Right. So I'm making the units match, and then I can set the problem up.
Correct.
Okay. So that's what I've been doing this whole entire time, but I'm having problems doing that, like picking out what I have to convert first on these two-step questions.
So what I start off with is I always account for the weight, because these two-step problems have weight. So I would, like, my strategy is take care of the weight first. So if I'm going to eventually get to the ordered over have, like you're doing, this is how I would do that. I would take the patient's weight, convert it to kilograms. So I'll write that out again. As long as you know to just divide by 2.2, you're doing the same thing I'm doing. I just find that if I write it out, sometimes you can at least see where I'm getting my numbers from.
Yeah.
Okay. So I get 33.181818, and I'm just going to round that to 33.2. But even if you didn't, you're just going to multiply. Now that you have it in kilograms, now you're going to multiply by this factor here where it says 3 milligrams per kilogram. So I'm just going to multiply that number by 3. So times 3, and I'm going to get 99.5. I mean, there's numbers after that, but you're just going to round to the nearest 10th. And that's going to be milligrams. So we've accounted for the kilograms. Now I can do, once I have it in milligrams, now I can do my ordered over half. 50 milligrams, 2 milliliters. But you have to do all these workup steps first. The step, we'll call that step 1, even though it seems like there's 3 steps here to get to the second step, which is what you've been doing, the ordered over half.
Okay.
Yeah, so I would just say as a strategy, start with the patient's weight first, convert pounds to kilograms. Then once you know that, take the kilogram body weight times whatever they tell you is the milligram per kilogram, and then you can do ordered over half.
Okay, thank you.
You're welcome. Yeah, unfortunately, there's no shortcut with a lot of these things. It's just you have to keep like kind of practicing and practicing until you get it. And you guys are 3rd semester, so you'll have pediatric dosages this semester, and you'll dive into this a lot more with the weight-based medications. Yeah, you'll get really good at it whether you want to or not. All right, the parenteral medications, the IV push, the SCIM, just remember those are all basically the same thing as our 1-step problems, but instead of talking about oral based meds, these are injectables, but injectables are calculated the same way you would calculate a liquid oral medication. So as long as you feel good about doing liquid oral medications, you're going to follow the same process. The other thing is, anytime you see IV, SC, or IM, you know that your answer is going to be in milliliters, okay? Because you can't push, right, a tablet or a capsule through a syringe, okay? Not without first powderizing it, putting it in water, and making it soluble. You can't do that, okay? So when you do these, make sure you're paying attention to what they're asking. So if they tell you IV, you know that it's going to be in milliliters, okay? Sometimes it'll give you a time. That time is only important if we're talking about a flow rate. And in this particular question, at least these types of questions, they're not talking about flow rates. Sometimes it'll tell you a healthcare provider has prescribed furosemide or is prescribed 30 milligrams every 2 hours. And then we have to look at the label to see what to do with that information. So you notice the label says 20 milligrams, but then in parentheses, it says 10 milligrams per milliliter. The 10 milligrams per milliliter is what you want to use to find out how many milliliters you're going to administer to the patient. The 20 milligrams is if you use the entire 2 milliliter vial, right? So now you can see where that 10 milligrams per milliliter is coming from. Is the total vial is 2 milliliters. So 2 times 10 is 20, or 20 divided by 2 is 10. But if I'm calculating this out, 30 milligrams is my order over my available. Sorry, that's supposed to be a 10 per milliliter. And then you're going to get 3 milliliters as your answer for this particular question. So your IV pushes, your SCIM, your oral-based medications, they all will work really well with the ordered over half, if that's what you do, or desired over half, if that's the method that you utilize. If you have to do a 2-step problem, just remember to account for the patient's weight before you move on to your ordered over half or your desired over half. This is a similar question. Now here it doesn't really tell us what this is. It just tells us, 350 milligrams by accident every 12 hours. And then it has some other questions. So this is kind of like a reconstitution questions, sort of, but I think the way this question was put together wasn't exactly helpful for you. But if I'm looking at this, I'm seeing that Biaxin granules for oral suspension. So this is actually an oral suspension question, not a injectable question. But notice that the available after it's been reconstituted, it tells you 125 milligrams per 5 ml. So if I'm doing this particular problem, if the question is how many milliliter or how much would you administer or how much would you, or mark the syringe, whatever the case may be, I'm going to do the same thing we did in the previous problem. I'm going to take my order and I'm going to do my available times my quantity. So all these other things don't really, we're not worried about this. Obviously we didn't know the milliliters diluent added. We would probably have to see that on the label. But this doesn't look like a reconstitution question because it's giving us the details we need in the label. So it already tells us what it would be once it's reconstituted right there on the label. So we have to look for it. If you remember what reconstitution questions look like, and we'll have I'll show you a couple of those in a little bit. And then just so you don't, just in case, sometimes it's helpful just to at least see that I've calculated and you got the same answer I got. So I do 350 times 5 divided by 125, and I'm going to get 14 ml. And as always, if you do have a question, feel free to unmute or just type into the chat and say, hold up, I got a question. And just let me know. All right. So I think last semester you should have had a couple flow rate questions. If you didn't, I can show you a couple of those. This is just your basic slide and scale question. I think for the most part, you're probably fine with these, where basically you look at the sliding scale. It tells you, what their blood glucose is. So if it's 245, how much, now this says how much regular and how much NPH, but this question is a little bit worded unusual, but you would just, for these simple sliding scale questions, and like I said, I'm going to get some more clarification from Professor Geyer on that type of question, or where I can get a sample of it. But if I'm looking at this, I look for the range. This range of 221 to 280 says to give the patient 4 units. So that's where that would come in. As far as, okay, yeah, so there's basically like 2 questions here, but I need to find out how you would differentiate regular from NPH when it doesn't give you any of the information to differentiate that. This question this question here is just not completed. So, but anyways, like for this question where it says 200, then you would give them 2 units. If it was 300, you'd give them 6 units. If it's, 375, you give them 8 units. If it's above 400, then you would call the doctor. I found that I think someone missed a question like this last semester, and I can't remember what happened, but it was like a silly mistake. You don't need to convert anything in this particular question, because sometimes it'll tell you, it'll show you a picture of an insulin bottle, but insulin is administered in units. So you don't give milliliters, at least as far as writing that down. Your syringe is marked in units, so you don't need to convert units to milliliters. You could, but you don't need to when it comes to insulin. Now, you might see an infusion question that might look something like this. Did you guys have infusion questions or flow rate questions last semester?
Yes.
Okay. So I just want to make sure it's not like a completely new concept. But so whenever you have a flow rate question, remember, it's kind of like you drive your car, your car has a rate and it's miles per hour. If you're in Canada, it'd be kilometers per hour. when it comes to infusion rates, we're talking about IVs, and IVs are going to use one of two things. It's either going to be milliliters per hour, or it's going to be drops per minute. And so that's usually abbreviated GTT. Okay. So we always have to look at and see what we have available. So this says, what would we set the infusion pump to if we have insulin infusing at 6 units per hour, and then the insulin is 125 units in a 250 milliliter IV bag? So the flow rate questions, unfortunately, are not good questions to do ordered over have with. What I find is ideal is just making sure you can do your kind of simple conversion type questions. So usually what people will do and what students will do is they'll start off with, what is my initial rate, 6 units per hour. And then we're going to convert the units per hour to milliliters per hour. And we're going to do so by eliminating units and converting it to milliliters. According to what I have available, 125 units, 250 ml. Now, you could do 6 units. So you could technically do an ordered over have with this. You just got to remember it's 6 units per hour over 125 units times the 250 ml. So it would get you to the same answer. But I find that it might be beneficial to write it out, as much as you might hate it, the way I'm writing it out. That way you can see what's being canceled and then what's left over after you cancel. Okay. And so for this question, you would take 6 times 250 divided by 125, and you're going to get 12 units per hour, or sorry, 12 milliliters per hour. With infusion rates, from what I understand from rounding rules, like you could get like, 12.3 milliliters per hour. You could get that. You may not in a clinical setting be able to program it to the nearest 10th. You probably just go to the nearest whole number. But when we're in the what I call the CCAC math bubble, you just do you follow the rounding rules. When it comes to drops, you can't round a drop. You have to give the nearest whole drop. All right, so you will have a reconstitution question. For a question like this, the Omnicept, this is technically not a reconstitution question because it gives you the suspension information. So I think, we worked through one of these already. So let me continue on. But make sure you're looking at your labels. I always tell students a good strategy is to go in, go on, do a Google search and just say, let me see some images. Let me see some image, or do an image search for different drug labels so you can have an idea what some of these things look like so you're not caught off guard. Because most of them look very similar and consistent. I think that's because that's the law. But the reconstitution labels are the ones that usually look a little bit different. And I'll have an example of that in just a moment. Okay, so this is technically a 2-step infusion question. And I have seen this question on like the 240 test. I don't know that I've seen it on the 230 test, and there's a good chance that I just copied and pasted and added this when I was doing a review for 240. But let me show you how you would kind of navigate this, because if you can do this problem, then you can do a lot of problems associated with this. Now, when it tells you an infusion rate, you should automatically think milliliters per hour. If they want to know drops per minute, they're going to have to tell you that there's a tubing involved. So either they'll tell you it's a micro tubing, or they'll tell you what the drop factor is. but it needs to tell you that. And so in this question, it just says dopamine infusion to begin at 5 micrograms per kilogram per minute with a patient weighing 70 kilograms. The dopamine available is 400 milligrams for 250 ml. And then what should the nurse begin the infusion? So I'm just telling you what my thought process is I'm trying to get this to be milliliters per hour. Okay. So I'm kind of starting with that in mind. Again, if I thought this was drops per minute, I would see something about tubing in this question. There's nothing about tubing in this question. Okay. So I'm going to tell you to do and I'm going to be very consistent with what I've been doing is I'm going to account first for the patient's weight, the 70 kilograms, and I'm going to multiply that 70 by the 5 micrograms per kilogram per minute. And the reason I'm doing that is because I'm trying to get rid of kilograms first and foremost. So 70 times 5 is 350. I guess I should show you where I'm getting this from so I don't skip steps. So I'm starting with the patient's weight, and I'm just multiplying it by that first step, which is the micrograms per kilogram per minute. When I do this, I'm going to eliminate kilograms. So I'm going to be at 350 micrograms per minute. Now, this question is a little bit obviously challenging, and it's intentionally challenging is because it's getting you to think or getting you to do more steps in order to get to your final answer of milliliters per hour. So at this point, there's a couple things you need to keep in mind. Your available is 400 milligrams per 250 ml. Okay. You have micrograms and you have minutes. You need milligrams and you need hours. Okay. So some of that stuff you can do in subsequent steps. So there's no one right way to do this, but you just have to kind of go through the steps. So I'm going to kind of just go and do this a very stepwise fashion, utilizing dimensional analysis, just so I can show you this and what's happening here and explain what my thought process is when I'm trying to figure out a question like this. So I know that I'm trying to get to milliliters per hour. That's the end goal. So we know we're trying to get to milliliters per hour. So what I need to do is I need to kind of keep in mind the steps to get to that point. So you might want to start off with, okay, well, I know I need to convert minutes to hours. And I know that there are 60 minutes in 1 hour. So you might want to do that conversion first. I think that would be a good first step. Okay. So you can equal this at this point if you want to, but I'm just going to continue on with the dimensional analysis. Okay. But before I move any further, I can see now that I'm in hours. I've accomplished that step. Some of you prefer to do that step last. It's completely up to you. The next thing I need to do is I have to convert micrograms to milligrams. So I need to remember how to do that conversion. And if you go back up to the top of this page or you have it memorized, you know that there are 1,000 micrograms in a milligram. And then what I'm doing here is I'm setting this up so that I'm in milligrams per hour as opposed to micrograms per minute. Once I'm in milligrams per hour, now I can do and I can account for my milliliters. Okay. So remember, we know we're looking for milliliters per hour. And if you didn't know that, that's, kind of why I'm trying to explain that to you is it told me we're doing an infusion. It's a rate. There's no microtubing listed there. So I know I need milliliters on top and I need to get rid of milligrams. So I'm left with just hours on the bottom. The milligrams listed is 400. The milliliters listed is 250. And what I'm going to do is I'm going to make sure that the only thing I have left after I do all these steps, and like I said, I don't think you're going to have a question like this, but it's sometimes helpful to kind of see how these things kind of how they work through, and at least give you maybe some flashbacks and nightmares from chemistry class. And you can see that I've crossed everything else out, and the only thing I'm going to be left with is what I'm looking for, which is milliliters per hour. Then the last thing I would do is just multiply across the top, divide by the bottom. So I'm going to take 350 times 60 times 250, and that gives me 5,250,000. Okay. Then I'm going to divide by 1,000. That gives me 5,250. I'm going to divide by 400. And that's going to give me 13.125. So because we don't know otherwise, and because we're following CCAC rounding rules, that 13.125 mil per hour would be rounded to 13.1 milliliters per hour. So like I said, I've only really seen this as a practice question. I haven't really seen this as a question that I think you're going to see, but it is helpful to kind of see how some of these questions could be asked. You might see this on an ATI. I doubt you'll see this on your NCLEX, but it might be worth seeing if you haven't seen it. All right, let's move away from that because I'm sure some of you just got a headache. Let's go to a reconstitution question. So there's a couple things that you need to know about when you're identifying. So if you, I know I recognize some of the names on here. I recognize Mandy's name, so I know that you've been on a couple of my previous reviews. With the reconstitution, there's a couple of clues. Okay, so even if it just gives you this here where it says, you know, all we see is the order down. Okay, so I don't see the sorry guys, I don't see the below or above, you know, where it gives me a bunch of extra information. It just tells me the order and then it gives me a label. So in this, my order is the 0.375 grams. Intramuscular. Remember, I told you with intramuscular, you already know how this is going to be administered. It's going to be administered via milliliters. Okay. Intramuscular tells you milliliters. The only time that this would not be milliliters and it wouldn't be intramuscular, it would be subcutaneous. It would be if it was an insulin, and then it would be in units. But insulin isn't going to be a reconstitution. What a reconstitution is a powdered substance that in the pharmacy they will add, or maybe in certain healthcare facility situations, they're going to add water to powder to make it into an injectable substance. Okay. So the clues that you're dealing with the reconstitution is, if you know you're looking for milliliters, but then you come to the label and it just says 500 milligrams. It doesn't tell you anything else about volume. If you look at the main label, there's nothing on here saying anything about volume. It's not 500 milligrams per milliliter. You can't assume that. Okay. So that's your clue that you need to look at the label. Okay. So you need, or look at the directions on the side of the label. Okay. When you do that, it's going to give you a couple things. It's going to tell you the usual adult range. We'll assume that's correct. So 250 to 1 gram. This is 375 milligrams. So we're good. It says for intramuscular, which we're doing, we're going to add 2 milliliters of sterile water for injection, shake well, withdraw entire contents, and it provides an approximate volume of 2.2 milliliters. But the thing I'm really looking for is, what is my concentration? What is my available? My available is actually 225 milligrams per milliliter. So that's what you need to look for. Okay. So they're all going to be hidden like that to some extent. They won't be hidden anymore because now you've seen a couple of these. And I'll show you, I think there's one more on this page. What we're going to do then is I'm just going to quickly convert 0.375 grams to milligrams. So that's just 375 milligrams. And then if I'm doing ordered over half or ordered over available, my available is 225. And then times my 1 milliliter. And then I'm just going to take 375 divided by 225. I'm going to get 1.6 repeating. And I'm just going to go ahead and round that to 1.7 milliliters is how much I would administer. These other questions down here, you're not likely to see. These were just copied out of a most likely a textbook of some sort. And then so they just, it was basically how to kind of go through this stepwise. But if you wanted to challenge yourself, you could go through these and you could say, okay, well, how many milliliters of diluent was added? 2 milliliters. What is the dosage strength of the reconstituted solution? That's the 225 milligrams per milliliter. How many milliliters will you administer? And that would be the 1.7 milliliters given the order. And I think there's another one. I just wanted to show you. I think there's another one on here. Maybe there's not. No. Okay. All right. Drop factor. So the you're going to see 5 questions referring to flow rate calculations. When you're dealing with flow rate calculations, you need to know 2 pieces of information. You need to know the volume and you need to know the time. You do not need to know the strength. The strength is important. Obviously, you want to administer the correct strength to the patient, but when we're calculating flow rate and we're asking for flow rate, all I care about is volume and time. So whenever you see, 60 milligrams, 375 milligrams, 100 milligrams, you get rid of that and it does not factor into your equations. Okay. It's good that it's there. We want to make sure we're giving them the right thing. But as far as calculating and doing the math, it doesn't tell us what to do with the flow rate. So what I need is volume and I need time. So it tells you here 50 milliliters over 15 minutes every 6 hours. Okay. Now there's a couple of extra information here, and then I'm trying to think of if there's the way that this should be answered, but I'm going to answer it the way that makes the most sense to me. I'm going to prioritize the 15 minutes because it tells us 50 milliliters over 15 minutes. And then to repeat it every 6 hours. So I need to know what I'm administering right now. I doubt you're going to see a question like this where there's 2 times listed here. So what I'm going to do is I'm just going to eliminate that for the time being. I'm going to double check the key, but I don't think that that's part of the equation. The other thing is, how do I know I'm calculating flow rate, milliliters per hour, or drop rate? The clue is they'll give you a drop factor. Now you need to know sometimes, because sometimes they just tell you 20, that's 20 drops per milliliter. That's what the drop factor is, or the tubing factor, sometimes it's referred to as. So when I'm calculating a drop factor or a drop rate, I need to know 2 things. I need to know my flow rate, and I need to know my drop factor. That will give me my drop rate. Flow rate is typically milliliters per hour or milliliters per minute. Could also be cc's per hour, cc's per minute. It's supposed to be a minute. My drop factor will always be drops per milliliter. And my drop rate is going to be drops per minute. If for some reason they don't tell you the drop factor, but they say something like microtubing, that is 60 drops per milliliter. And that might be something you need to know if they don't give you the drop factor. I can tell you, like at Allegheny campus, they get told the drop factor, but I always tell them the same thing I'm telling you, is that if you're like on an NCLEX or ATI and you ask a question about microtubing, then to make sure you're utilizing the microtubing information, which is 60 drops per milliliter. So if I'm solving this question, I'm going to start off with my flow rate, which is 50 milliliters in 15 minutes. Now, because this is in minutes and I'm looking for a drop rate that's drops per minute, I'm not going to convert minutes to hours. I'm just going to take my 50 milliliters per 15 minutes and I'm going to multiply by my drop factor, which is 20. And you can see that it's going to leave us with what we're looking for, drops per minute. So 20 times 50 divided by 15, it gives me 66.6 repeating. Now, drops we can't give someone a partial drop. So you're going to round it to the nearest whole drop. So you'd say 67 drops per minute. And then you repeat that every 6 hours. So I just wanted to double check that the key says the same thing. Oh, what number is that? 9. The numbers are all over the place. Okay, so she got 67 drops per minute. She also had 200 milliliters per hour because it didn't clarify specifically what the flow rate was. But if they have the drop factor there, most likely they're looking for the drop rate. If they were just looking for the flow rate, you could do 50 divided by 15 times 60, and that's where the 200 comes from if you see that in the key. But I would say if they gave you the drop factor, most likely they're looking for the drop rate. A lot of these are pretty straightforward, although commonly missed, mainly in second semester. But again, remember, flow rate is just volume over time. So I'm going to take 375 divided by 3, and that'll give me 125 milliliters per hour. Sometimes you'll get a question asking, what is the flow rate? This question is not asking what the flow rate is because it's listed here, 100 milliliters per hour. What they're asking for is how long will this infusion rate last? Okay, so that would be the better question. So if we say what is the flow rate is 100 milliliters per hour because it tells us that. What the real question is how long will this infusion run? Okay, so how many hours, how many minutes? So if I have the way you would solve something like this, you would start with the 250 milliliters and then just divide by the 100 milliliters times your hour. So 250 divided by 100. And this would run for 2.5 hours. And then it would need to be replaced. So notice I did basically an ordered over half with this approach, which is perfectly fine. I took my 250 milliliters is what I have. That's my total bag. It's infusing at 100 milliliters per hour. And then I was able to get to how long will the infusion run? It will run for 2.5 hours. Keep in mind when you're dealing with minutes and they're asking for flow rate, you might have to convert that to milliliters per hour. The only time you'd leave it in minutes is if we're talking about a drop factor question or drop rate question. And they'll usually tell you that there's a drop factor or it's microtubing. Remember, I repeat myself intentionally because it's sometimes like just in the few minutes you might say like, oh, I forget. So 120 milliliters in 90 minutes. If I'm doing this, there's two ways to do this. You probably already know that 90 minutes is the same thing as 1.5 hours. So that's one way to do it. 120 divided by 1.5. Or you can take your 120 milliliter 90 minutes and then just convert minutes to hours. Either way, you're going to get to the same setup. So 120 divided by 1.5 will give you 80 milliliters per hour. And then this would be the same answer. Either way you do it. This one's pretty straightforward. 800 milliliters, 8 hours. 800 over 8 would be 100 milliliters per hour. All right. Now, your heparin questions are going to be a little bit different than what they do at Allegheny campus, which I think is a good thing. They're going to give you some information here, like to calculate the bolus, to calculate the IV rate, and they're going to give you the basic information. So this is where you're kind of tying in together a lot of these things that you've been practicing and you've done. So this is kind of the new thing that's probably there for you. It tells you that your initial bolus is 80 units per kilogram body weight. As soon as you see kilograms body weight, you know that you have to factor in the patient's weight. Okay. Then you're going to start a drip at 18 units per kilogram per hour. So again, if you see that kilograms, that tells you you're factoring in the patient's weight. They tell you the patient's weight is 110 pounds. Then it gives you your available. You have an IV of 25,000 units and 250 milliliters half normal saline. And you have a bolus dose of 1,000 units per milliliter. So when you calculate the bolus, you're going to use the bolus dosage strength. And when you're calculating your flow rate, you're going to use your IV. All right. So step one is we need to convert the patient's weight in pounds to kilograms. I'm just going to write that up here. I think at this point, we all know that it's just divided by 2.2. And I'm going to get 50 kilograms. So the first part of this question is calculate the number of milliliters to administer for the bolus. So I'm going to look at a couple pieces of information. It tells me the bolus the patient with 80 units per kilogram body weight. And my bolus dosage strength, so again, bolus is 1,000 units per milliliter. So what I'm going to do is I'm going to use that information to find out how many milliliters to administer, because this is heparin. It's a heparin infusion. And then whenever we have, whenever it tells you 1,000 units per milliliter, it tells you it's an injectable. Okay. And what they're doing is they're injecting the bolus dose into the port of the IV to kind of get things started with this, what's called heparin protocol. So you're going to take the patient's weight, 50 kilograms, and you're going to get rid of that by multiplying by the 80 units per kilogram. Okay, so step one, account for the patient's weight. So 50 times 80 gives me 4,000 units. Now, if I wanted units, great, that would be my answer. But with heparin, we don't want units because it tells us we're looking for milliliters. So I'm going to use my bolus dosage strength of 1,000 units per milliliter. and then I'll get an answer of 4 milliliters. So that's how you would calculate the bolus dose. Now, obviously, the patient's weight's not always going to be an even number. So you might get an answer of like 4.3 milliliters, or you have to round to the nearest 10th. Again, that's possible. You've all seen syringes that go down to the 10th and even into the 100th and maybe even into the 1000th. But for numbers greater than 1, remember you round to the nearest 10th. For the infusion rate, remember, if it doesn't tell us to calculate a flow rate, or if it doesn't tell us anything about tubing or tubing factors or drop factors, then we know we're looking for milliliters per hour. It tells us to start a drip at 18 units per kilogram per hour. It tells us we have an IV bag of 25,000 units of heparin in 250 milliliters, half normal saline. So we're going to use that information to convert the patient's weight and eventually get to our milliliters per hour. So I'm going to follow the same strategy I did up here, where I'm going to start off with the patient's weight. And then I'm going to multiply by what I'm starting with, which is the 18 units kilogram hour. So we're going to get rid of kilograms. 50 times 18 is 900 units. Now this is per hour. So there's a couple ways to do this. I'm just going to do it this way. And then this is where the previous practice questions will kind of help out, because we already did something similar, right? Remember, we did an insulin that was in units per hour and we converted it to milliliters per hour. So we're going to do basically the same thing here. And we're going to use our IV to do that conversion. So I have units down here because we're trying to get rid of that. And milliliters up here. Again, I'm going to use my IV solution, 25,000 units, 250 ml. And then we're just going to multiply across the top, divide by the bottom, and we're going to get 9 milliliters per hour. And then, as I've mentioned before, sometimes that might be, 9.5 milliliters per hour, 8.2 milliliters per hour, round to the nearest 10th. You may not be able to do that clinically in real life, but in the CCAC math bubble, round to the nearest 10th, unless you have been taught otherwise. Now, some of these questions will continue on. It'll tell you, this is basically the same thing, starting an infusion at 18 units per kilogram per hour. Now you have a patient that weighs 75 kilograms. So it already tells you how many kilograms, so you don't need to convert pounds to kilograms. The infusion bag is just a little bit different, 500 milliliters, 25,000 units, but it still wants to give us the milliliters per hour. So just so I feel confident, why don't you try and do this one? And when you get an answer, just put it into the chat. Or if you want to privately just say, I don't know, that's fine too. All right, looks like we got some answers coming in. Let me just see if I got the same thing. Good. Yeah. So I got the same thing. I got 27 milliliters per hour as well. And then most likely what you did is hopefully, I mean, even if you did it differently, this is how I'm doing it. 18 units kilogram hour. 75 times 18 gives me 1,350 units per hour. And then I'm going to convert units to milliliters. I have 25,000 units. I have 500 milliliters. And that's where I'm going to get the 27. Sorry about that. $27 milliliters per hour. Good. Good. And then this will just give you a different variations of this. So I'll let you guys practice some of these. If for some reason you have a problem answering any of these questions, please email me, and I will I'll help you out, or at least give me an idea of what to focus on in the next unit of questions, or this afternoon. So you can practice some of these. Some of these, like I said, I added from another like the 4th semester. So I added some 240 questions here. So if there's some things here that seem tricky, like I said, you can just email me and I'll make sure I answer those for you. So all right, well, and if I don't see you before, I hope you do well on your test on Tuesday. But like I said, you can reach out to me if you have any questions via email, or I'll see you this afternoon.
Thank you.
You're welcome.
Thank you.
You're welcome.